Hello everyone, myself Mohishan Gowda. I'm from Honda section studying in Sri Venkateswara College of Engineering. Today I'm going to talk about key issues in waste disposal for different types of waste. Introduction to waste disposal. Proper waste disposal is crucial for maintaining a clean and healthy environment. This section provides an overview of the key issues and considerations in managing different types of waste, from households to industrial facilities. Household waste disposal. Sorting waste. Separate household waste into different categories like dry, recyclable, wet waste, and hazardous items for proper disposal. Recycling. Recycle paper, plastic, glass, and metal items to reduce the amount of waste going to landfills. Composting. Compost organic waste like food scraps and yard trimmings to create nutrient rich soil for gardens. Industrial waste disposal. Managing manufacturing waste. Industrial facilities generate a variety of hazardous and non-hazardous waste streams from their production processes. Proper waste management is crucial to mitigate environmental impact and ensure regulatory compliance. Hazardous waste disposal. Highly toxic chemicals, heavy metals, and other hazardous industrial waste require specialized treatment and disposal methods to prevent contamination. Rigorous tracking and manifesting procedures are essential. Recycling industrial waste. Many industrial byproducts can be recovered, reused, or recycled, reducing the volume of waste that must be landfilled or incinerated. Innovative recycling programs can enhance sustainability and generate cost savings. Medical waste disposal. Segregation. Proper segregation of medical waste into categories like sharp, infectious, and general waste is crucial to ensure safe handling and disposal. Incineration. High temperature incineration is a common method to safely destroy infectious medical waste, reducing its volume and rendering it non-hazardous. Autoclaving. Autoclaving uses steam under pressure to sterilize and disinfect medical waste before disposal, making it a reliable alternative to incineration. Proper labeling. Clearly labeling medical waste containers with the type of waste and appropriate biohazard symbols is essential for safe handling and transport. Electronic waste disposal. Growing problem. Electronic waste or e-waste is one of the fastest growing waste streams globally. It includes discarding electronic devices like computers, phones, TVs, and appliances that contain hazardous materials that require special handling. Environmental concerns. Improper disposal of e-waste can lead to the release of toxic substances like lead, mercury, and cadmium into the environment, contaminating soil and water sources. This poses serious risk to human health and ecosystems. Recycling solutions. Responsible e-waste recycling involves dismantling devices and recovering valuable materials like metals, plastics, and glass. This reduces the need for extracting new raw materials and mitigate environmental damage. Regulations and policies. Many countries have implemented laws and regulations to promote proper e-waste management, such as extended producer responsibility and e-waste collection schemes. Compliance with these policies is crucial for sustainable e-waste disposal. Hazardous waste disposal. Identification. Hazardous waste includes materials that are toxic, flammable, corrosive, or reactive. Proper identification is crucial for safe handling and disposal. Segregation. Hazardous waste can be segregated by category to prevent dangerous reactions. Incompatibility materials are stored and disposed of separately. Specialized facilities. Hazardous waste requires treatment, storage, and disposal at licensed, regulated facilities equipped to handle this material safely. Manifesting. Detailed records, known as manifests, track hazardous waste from the point of generation to its final disposal, ensuring accountability. Organic waste disposal. Composting. Organic waste like food scraps and yard trimmings can be composted to create nutrient-rich soil for gardening and landscaping. Anaerobic digestion. This process breaks down organic matter in the absence of oxygen, producing biogas that can be used for energy generation. Vermicomposting. Earthworms are used to break down organic waste, creating a nutrient-dense vermicompost that can be used as a soil amendment. Fill diversion. Diverting organic waste from landfills reduces methane emissions and preserves landfill capacity for other non-recyclable materials. Recycling and waste minimization. Recycling is a crucial component of sustainable waste management. It involves the reprocessing of used materials into new products, reducing the need for virgin resources and diverting waste from landfills. Waste minimization strategies such as source reduction and reuse can be significant can significantly reduce the amount of waste generated in the first place. This includes practices like buying in bulk, using reusable items, and avoiding single-use plastics. Regulations and policies on waste disposal. Governments around the world have implemented strict regulations and policies to engage waste disposal and promote sustainable practices. These regulations cover various waste streams, including households, industrial, medical, and hazardous waste. Key regulations often mandate proper waste segregation, collection, transportation, and disposal methods. They also set standards for waste treatment facilities, emission control, and landfill management. Policies may incentivize recycling, waste reduction, and the development of alternative waste disposal technologies. Enforcement of these regulations and policies is crucial to ensure compliance and mitigate the environmental and public health risks associated with improper waste management. Regular monitoring, auditing, and penalties for violations help drive the adoption of responsible waste disposal practices. Emerging technologies in waste management. Automated sorting systems. AI powered robots efficiently sort waste by type, improving biodigestion and composting. Anaerobic digesters and high tech composters transform organic waste into valuable biofuel and nutrient rich soil.